Hey everybody, this is Larry. This is the 5th day of the August daily challenge, daily Leetcode challenge. Hit the like button, hit the subscribe button, join me on Discord, and let's get started on today's problem. Add and search word data structure design. Okay. You have add word, you have search. Okay. Okay, so basically, so I think my first attempt is going to be just keep it simple, stupid, and then see if it works. I honestly don't know if there are any easy optimizations. So there are two ways that you can think about this, right? One is at least two immediate ways for me. One is to, well, in both of them you will use a try, right? And it depends on how many queries you get, how many AdWords you get, or how many searches you get, right? And the idea is that, okay, we can either add a period at each step, or when we add a word, we could add a period that matches all of them, which is maybe not that good. Or we can do it on the search. I think doing it on the search probably makes more sense in terms of space complexity. So that's what I'm going to do. And it's a little bit brute forcey, but the recursion is just that if you give me a dot, then just try all the characters, and then if one of them is true, then it's true. So it's kind of very straightforward. But now we just have to make sure that we the implementation part is the tricky part. Okay. So now what I want to do is I want to have a try class. So which is what I'm gonna implement as well. Okay. Maybe try node. And then I could add some APIs later, but maybe I'm a little bit lazy today. So let's see. But so what's in a node? A node will have just a list of edges, right? So let's just have a list of edges. And then also whether it is at the end. So I usually actually use denote n with an exclamation mark or something like that, or just some token. But we could also just use an explicit is n is equal to false, right? And then now when we add a word, we just have to put in a try. So so this is just an interface for the try. So add word is just try dot add word, and then return self dot try dot search word, something like that, right? So then now we have to implement add word, add self word. So okay, current is equal to self dot root. For character in word, if current has edge of char, if they don't have it, then current add edge of char, and then current is equal to current.get edge of char. And then at the very end, we do current is n is equal to true. And you can make these APIs, right? I mean, I think for now I'm just trying to focus on, and when you're in an interview, make sure you talk about these things, because you should keep it consistent. I guess we should do it then. But this is technically, and yeah, and then now for the search. And of course we have to implement these. So let's actually implement these first. Get edge. And that should return a node. I guess it's technically get node by edge, but And this assumes that this is not already in it, but oh, and there's a has edge. And set is end. Okay. And then now for search, we just have to go through it one by one. And the tricky part about this is, of course, we have to handle the wildcard, right? The period. Because otherwise it's just straight for loop. This is straight for a try. So I think I'm going to just handle this recursively. So, okay. So let's just say char is equal to word sub 0. And then, oh yeah, if word is equal to empty space, then we just return true. No, maybe not. Maybe we need a helper, I think, to take the node as well. So now we can just return search node of word and self.root. And then now the base case makes sense, which is with word is equal to, we can return node.isn. Otherwise, okay, if char is equal to do, then, I guess we need like a get all edge type thing, or get edges. So return self.edges.keys. I think that should be okay for the keys of these edges. Yeah. Then just, yeah, for edge in node dot get edges. If search node of word sub thing node well, node dot get edge of edge. Maybe this API naming is terrible, to be honest, but you know. And else, I guess this is actually return false here. Else we return node dot has edges or edge of this char, and self dot search node of word, and then node dot get edge of char. Is this right? Yes, that's the, yeah, okay. This is, now let's try it out real quick. Or as long as it takes, I guess. 35, some syntax error. Oops. Ooh, one-time error. $41. Does this not work? It's not editable. Is keys not editable? Print it out real quick. Maybe I have some weirdness. Keys. Oh, I see. I have to do this. Whoops. I forgot that it's not a property. That's a. Oh, snaps. What did I do? Okay. Oh, still. Oh. Yeah, I forget to do self.search node. Okay. Okay, so that looks okay according to this. So usually I would advocate more testing, and I definitely do recommend you do that at home. A little bit lazy, so I'm just going to submit. um, and the thing that I would worry about is just the running time, but it seems okay here. Yeah, so what is the running time? It's going to be a little bit tricky because it depends on the dictionary and stuff like that, because the wildcard we essentially branch out to as many as the dictionary allows. So it could be really bad in terms of exponential. But yeah, in terms of space, we store at most one node per character, so it's going to be linear in terms of the order input words. Yeah, seems to be okay. Let me know what you think. Hit the like button, hit the subscribe, and join me on Discord, and I will see y'all tomorrow. Bye bye.